So the diagram below, not drawn to scale, shows the cross section of a prism in the shape of a sector of a circle. Center O, radius 3.5 centimeters. Now they went on to tell you that the angle at the center is 270. Yeah?
Let me get to correct F3.
F3? Oh, we didn't do F3. Somebody else give me the answer for it now. What's the answer for F3?
55.43.
55.43? Somebody second now.
So I get 53 and 37.
Again, 55.43. I have 53 and 37. What the others got?
Yes.
Anybody else?
So the answer is 55.43.
So I get that too.
Yes, I got that too. 5.48.
43, right? Right, let me go. Right. Okay, we're going back down here, right? In the diagram, okay, I already read out this. They said the angle at the center is 270. Now, this 270 degrees they're speaking about here will be the angle within the sector, right? On the outside of the sector, we obviously have 90 degrees. So in here, this angle is what is 270 degrees, right? Now you barely see that how the shading is there. So I'm going to kind of like put an arrow and draw it on the outside, right? So this angle inside here is 270 degrees, right? So that will be my theta. So theta is equal to 270 degrees, right? Then we know that our radius, which is r, is equal to 3.5 centimeters. So we basically have the artillery to calculate everything they asked us for, right? But this question is similar to one like what we did above. So part A, part 3, no, part 1, sorry. We want to proceed to find the length of the arc. What is the formula for length of our arc, Caitlin Sinanan?
So say the formula too, right?
Yeah, what is the formula? The formula is what I want.
Length of r is equal to theta over 360 multiplied by 2 pi r.
Proper thing, all right? Okay, we have all our information here. When you plug it in, theta is 270, not 90. Theta is 270, right? Multiply by 2, multiply by 22 over 7, multiply by my radius of this question, which is 3.5. When we calculate all this together, what would we get here, Abijah? Abijah?
After calculating all that together,
Right.
we'll get 16.5.
16.5 centimeters. It's not square, that's the length, right? Somebody second this.
Yes.
Excellent.
Yes,
Right.
sir.
Looking
Yes, sir,
good.
that's correct.
We're looking good right now. B. Let me start a move, right? B. B is what they're asking us for, but the perimeter of the sector, right? So the perimeter would be equal to what, Priya? Perimeter. Priya. Priya, not hearing your sister. Hello.
Excuse, please.
Yeah, go ahead, Joshua. Priya, not hearing you. All right, I'm not hearing Priya. Let me go to Emma. What is the perimeter of the sector here if we found the length of the arc to be 16.5?
You'd add 3.5 plus 3.5 plus
Excellent.
16.5.
Excellent, excellent. 3.5 is here, right? And 16.5 is on the curve outside here, right? Okay? All right, so we're going to add that. 3.5 plus 3.5 plus 3.5 plus 16.5, which will give me what is my total here, crew. What you got for your perimeter, crew? Crew. I ain't hearing crew, and I wasn't hearing Priya just now.
So can I answer?
Yeah, go ahead, Empress.
23.5.
Somebody second 23.5.
23.5
Yes, sir.
sir.
Yes, sir.
Yes, sir.
Correct, sir.
Right. Right. And we proceeded to find the area of the sector now, right? Area of sector. What is the formula for area of this sector here, Rudra?
Area of a sector is theta over 360 by pi r squared.
Proper thing. Right? Plug in my stuff here. Somebody mic on by JL, sing your mic on. Right, Tyler, plug in these things to me, Tyler. What's theta? Look at here, Tyler.
Yeah, so I just calculate, yeah.
No, give me that. That's not the plug-in. What is theta?
Theta will be 270.
270 over 360 multiplied by 22 over 7 multiplied by what is my radius?
I think it was 18, I think.
No, what is the radius here, guys? Anybody remember the radius?
3.5.
3.5.
3.5 sir.
Right, and when we work it out, what are we getting?
So you're getting 28.88 centimeters squared.
28.88 centimeters squared.
Yes, sir.
Yes, sir, that's correct.
Yes, sir.
Everybody good here? Right, sector, right. We're done with that. Let me keep it moving. We ain't sticking today, right? Or we ain't sticking again, because we are sticking just now, fine. All right, this is basically the same kind of thing. That why I give you all these easy ones to find, right? So number 14, part A. Okay, I want to do some harder ones. So just give me the arc. The minor arc will be here, right? Let's go to raise your hand if you did this here. Anybody want to answer? Raise your hand and I'll call on somebody to answer. If you did this. I want the three things one time, right? Nathan, hit me the three one time. What is the length of the minor arc here, Nathan?
The length of the arc is 11.78 centimeters.
Right, somebody needs to second that.
Yes, sir.
Right. Nathan, hit me the perimeter one time.
41.78 centimeters.
41.78. Somebody confirm?
Yep, sir.
Yes, sir. Yes, sir.
Right, and Janaya, hit me the area of the figure. Janaya.
88.31.
Let me tell you something. Earlier is one of the first classes where I calling on so much people and so much people doing their homework. I just want to let you know I'm real proud of earlier. Like plenty people actually doing their homework, but are real good boy. Usually I start to be quarreling for homework. How many people got 88.31 centimeters squared?
Yes, sir. I get that.
Right. So that question done. Those who did not get it, go over, do your workings, and if you're probably still getting problems, you can message me and we'll figure it out, right? But we need to keep it moving right now. Right. And just this pool, no, this one here too. Right. Area of the minor sector. So let me analyze this drawing, right? Because this is a CSEC type question. This was from 2016, right? So the figure below, not drawn to scale, shows a circle with center O. We are the center O here. The radius of the circle is 21 centimeters. And the bring it in our plate now. And HOK, which represents the angle in the sector, is 40 degrees, right? So let me proceed to see what they asked us to find, right? They want the area of the minor sector, HOK, right? So this is simple stuff. Area, I'm just going to put here, area of sector, thank you. Area of sector. Area of sector would be equal to 40, which is the angle in the sector, over 360, multiplied by 22 over 7, multiplied by 21 squared. And when you work out this, what you get in here, Ford? Nathaniel Ford.
I don't know, sir. Trying to figure out what to do here.
Nathaniel, you was here last class?
Yes, sir.
So what you're not understanding here?
How to even do this?
When I say how to do it, how to calculate it on a calculator?
Still same thing as
I don't have a
you.
calculator.
Somebody else say same thing?
Yes, sir.
All right, what we getting problems with, like, how to... I'm not sure what we saying, like, how to
I
what?
have an answer.
Wait. Some people still getting problems with these things.
So I
Nathaniel,
think they must be getting trouble how to put the calculation in the calculator.
yeah, on the calculator, I think so too. Nathaniel,
Yeah.
you getting problems with like putting in the information, like how I write this first line here. You know how to do this line?
Not really.
You know the formula? What's the formula for area for sector?
Area of our sector is theta over 360 times pi r squared.
Right. What is theta in the circle here? Well, the sector we're dealing with, forget the rest of the circle. We're dealing with the sector HOK, which is this whole, let me highlight the whole sector, right? This is the whole sector here. Right, I'm trying to color it to the best of my ability here. Right. You see that there, Nathaniel?
Yes, sir.
That's the sector, right? What is theta? Theta is what? Theta is the angle in the sector, right? So theta is equal to the angle in the sector. How many degrees we have in the sector there, Nathaniel?
40 degrees.
All right. 40, right?
Yeah.
R is my radius, Nathaniel. What's my radius?
Radius is 21 centimeters.
All right. So you know plenty, Nathaniel. Your formula is theta over 360 multiplied by pi r squared. So we plug in theta as 40, Nathaniel.
I dropped my calculator just now. I dropped my calculator.
But just tell me do our calculator.
Oh, it was on my phone. I was using a calculator on my phone.
Nah, you gotta get a calculator. Hey guys, a very important part of this class is getting a scientific calculator. That's a very important part of this class. Please organize a scientific calculator, right? But for is who parent? Somebody parent message me today and tell me they organizing a calculator. Hold on, I don't think it's you, Nathan Sankar in here?
Yes, sir.
Right, Nathan, you don't have a calculator.
No.
But you understand what to do? Forget the calculator part. You understand what to do outside of that?
Yes, sir.
All right. So just the calculator, you had to get on perfect from there.
Yeah.
Right. So guys, when we get the calculator, you just plug in the information and you work it out because you can't go into CSEC with a calculator. Right, Ford?
Hey.
Right. Somebody else was saying they're getting problems here. Who else was it? Who else is getting problems here? Please ask the questions. Guys, I can't be going 100 miles per hour and then we have people being left behind and being left bad behind that they don't even know what's going on here. Anybody else have any questions? Please ask. Nobody's going to judge you here. So everybody in tune now. So when you get a calculator, right, guys, you're going to put in the fraction 40 over 360 multiplied by 22 over 7. And then you're going to multiply by 21 squared to the second power, right? You're punching all that as 1. You press equal. And what you get to it? Yeah, go ahead.
Oh, it was to that over 63.
You have a scientific calculator?
Yes, sir.
No, yes, I'm not sure it's in.
Yeah.
Right. You seen any fraction up there? You seen a and B over C nub? See if you seen this.
Yeah.
You see A and B over C. You see that now?
Yes, sir.
Right. So you're pressing 40. You're pressing the A over B, A and B over C now. You're pressing 360. Then you're multiplying it by 22. Same A and B over C now over 7. And then you're multiplying it by 21. And you're going to see a nub mark x to the second power. That is x squared. And then press equal and tell me again.
Right, yes, ma'am.
I don't run a class for how to use a calculator. I'll post some videos online, boy. You get you there? I'm not sure who this is, you know. Hey, it's Seki.
Akira.
Akira. We had to change our name for next week, eh? You get you?
Sir, just now.
Mm-hmm.
You could repeat what I was saying.
154 flat.
Right. So that's the area of the sector which is shaded in yellow. Now the question jump out and say, given that the area of the triangle HOK is equal to 141.73 centimeters squared. So what's something? I'm going to erase the yellow shading. All right. Wait, what's going on here? Hold on, eh? Right. All right. So I erasing this on it here. So you see where it's shaded now in yellow? That is the triangle. So they say the triangular part is 100 and how much by? 41.73. They want you to now calculate the area of the shaded region. Let me see. Who has any idea what we need to do there? Anybody? The area of the shaded region. Excellent. You say that?
Let's take it away.
Excellent. Right? Area of the shaded region is, remember the whole thing is the sector, right? And then this piece here is the triangle. So if I take away the triangle from the sector, that remain in the shaded region, Ran?
Yes, yeah.
You understand what I just say?
Yeah, for the area, the shaded region.
Right. You take the area of the sector, which is 154, you minus the area of the triangle. And what we get? What's the area of the shaded region?
Start working it out now, sir.
Brother, we didn't come here for that. You're supposed to do that for homework. Anybody else? What we get?
12.27.
12.27.
Yes, sir.
12. Yes, sir, that's correct.
Centimeters squared, right. Area of the circle. What's the formula for area of a circle, my children?
Pi r squared, sir.
Pi r squared.
Right, easiest thing in the world. So pi will be 22 over 7 multiplied by radius. What is radius?
21.
21, sir.
21.
21, sir.
21 squared, which will give me what?
1,386.
1,300. Yes.
1,386 centimeters squared. We find the area of the circle. Now they want the length of the minor arc. What is the formula for the length of the minor arc? The length of, when they say minor arc, right, is basically if they say minor arc HK, what's something? If I have 2 points HK, right, you could have a major arc, which is this big part of the circle, the circumference here. That is the major arc. That piece on top, that big piece is the major arc, right, Kaylee? Kaylee, that big piece is the major arc. So the smaller piece would be the minor arc, which is actually connected to my sector underneath here, right? That we're looking at. So we're going to find the length of the minor arc, which is the smaller piece down here. So what is the formula for length of an arc? Let me see if Akira, tell me what's the formula for length of an arc. I want to see if you know the formulas, Akira. Akira. Akira going by. Ford, what's the formula for length of an arc?
The length of our arc is. Put that way.
So I can see it.
Yeah, go ahead now.
Can I help you too?
So is
Welcome.
theta over 360 times 2 pi
Multiply by
r.
2 pi r.
Pi r.
Right. So we just plug it in thing, right? Theta in this case was the 40 over 360 multiplied by 2 multiplied by pi, which is 22 over 7 multiplied by radius. What's radius? Radius is 21.
Yes,
All right, look
sir.
at this. Wait again.
7.3, sir.
Somebody check on this.
7.3, sir. It's
We looking good. Last thing here, what's the formula for circumference of a circle?
2 pi r, sir.
Yeah, 2 pi r.
2 pi r, sir.
So there'll be 2 multiplied by 22 over 7 multiplied by 21. What is the circumference of the circle?
132.
Yes, sir, that's correct.
Right? Anybody have any questions here, guys?
No, sir.
Oh, 14 point.
6-7, if you round it up.
Right, 14.67 is the length of the minor arc, not 7.3, right? So the people who get 7.3, I think they didn't multiply by this 2 here. Probably forgot to multiply by the 2. Right, guys? I'm going to pause this, hold on. Right, the diagram below, not drawn to scale, shows the plan of a swimming pool in the shape of a rectangle and 2 semicircles. So the question straight up tell you what the compound shape is made of, right? It's a rectangle in the middle and then 2 semicircles on the ends, right? So the rectangle has dimensions 8 by 3.5. Now what I'm going to do here is I'm actually going to draw the diameter here. So it's like have a diameter there. It's not seen, but it is there. And another diameter here for each semicircle, right? Everybody good there so far?
Yes, sir.
Yes.
Right. So we have the diameter. Right. So you're seeing it clear now. So it's like 3 shapes you have. It's actually like 2 shapes, right? It's like a circle and a rectangle. But we'll call this A, and then B and C would be the 2 semicircles on either side, right? So they want you to state the length of the diameter of the semicircle. We already figured out that. What is the length of the diameter of the semicircle here, Melika? What is the length for the diameter? Excellent, 3.5 meters. All right? That is my diameter. Calculate the perimeter of the swimming pool. So in order to find the perimeter of the swimming pool, what we need to find here, Abijah? If you want the perimeter of the swimming pool, Abijah.
In order to find the perimeter of the swimming pool, sir, we have to multiply 8 by 2.
8 by 2 will be the perimeter of the whole swimming pool. The swimming pool is just here and here.
First we have to find
here
the rectangle.
to here. Which rectangle? What does perimeter mean?
Distance around the shape.
Distance around the shape. So, if we want to find all the lengths around the shape, what is missing here, Abijah?
The diameter of a semicircle.
So this diameter is the other 2 lengths that missing?
Yeah.
Somebody help him. Anybody, raise your hand if you want to help him.
Sir, can I try?
Yeah, what is missing, Amelia?
The formula for rectangular is length multiplied by breadth.
Is this perimeter? Is this
Trying to find
perimeter?
the perimeter. Yes, perimeter. So we need to find the distance around. Anybody wants to say, how do we find the distance around the swimming pool?
So yeah, the family arc first.
Somebody said arc. Somebody said arc. We have an arc here, and we have another arc here. Okay? So you need to find this length, which will actually be the same distance on the next side. Right? We need to find the length of the arc for the semicircle. Okay? What is the formula for length of the arc?
Theta over 360.
But 360 multiplied by 2 pi r.
2 pi r.
Right. Now, I hear people belting out this formula very good, but then somebody mic on. I hear people belting out these formulas excellent, but then when it comes that time to use the formulas, we're not sure what to do, right? We're looking at a swimming pool here, guys, right? If I want the perimeter of the swimming pool, right, I want to highlight it because I'm not sure where we were looking at. If you want the perimeter of the swimming pool, right, what the yellow highlight is this length, obviously, right, plus this length, which is our arc, right? Okay, plus this length here, which we know is 8, right? Then plus our next arc. Look at next arc here. So I'm not sure who wasn't seeing it, I'm not sure where we were looking. The only distance are wrong. So from that perimeter there, we already have the 8 and 8. So all we need to actually find is the length of the arc. The length of one arc would actually be the length of the next arc, right? So both of the lengths are the same, right? So let's work. So we go in theta over 360 multiplied by 2 pi r, right? Right. So what is the theta in this semicircle here, which is actually a sector, right? What is theta in a semicircle? How many degrees do we have in a semicircle? Anybody?
90.
180.
180, sir.
180.
Proper. 180 degrees, right? So it'll be 180 over 360. So it's like a semicircle is simply like half of 2 pi. Wait, let me put in what pi is. Let's put in what r is, right? So pi would be 22 over 7. And what would my radius be here, guys? Because the diameter is 3.5, you know. What would the radius be?
1.75, sir.
Right, 3.5 divided by 2 would give me my radius. And when we work out this as 1, what do we get here, guys?
1.75, sir.
I got 5.5.
Yes, sir.
5.5 for the answer, sir. 1.75 for the diameter.
Yeah.
For the radius.
Diameter. Radius, yeah, very good, Isaiah. So it's 5.5 is the answer. Is it centimeters? Meters, sorry. Right? Now, this arc here would be 5.5, which means the next arc is same 5.5. So if I want the perimeter, therefore, therefore, perimeter would be equal to, come on, give me what we adding up here, guys. What we adding up?
5.5.
5.5 plus
5.5.
Right, plus
5.5 plus 8.
5.5 plus 8 plus 5.5 plus 8, which will give me what?
27 centimeters.
27.
Excellent, my children. And let me go on to area of the sector now. Right? Right. Well,
So-
sector, area of the swimming pool. Somebody asking something?
Is 27 centimeters or 27 meters?
Is meters, sir.
Thank you very much. Meters. Right. So there we go. Area of the swimming pool. So we have 3 areas. We have area of the rectangle, right? Area of the rectangle will be length multiplied by breadth. I believe it was 8 multiplied by 3.5. 8 multiplied by 3.5 is what?
28
28.
meters.
28 flat.
Yes, sir.
Yes, sir.
Putting centimeters again as meters squared, right? Now, if 2 semicircles come together, they simply form a circle, guys?
Yes,
Guys, so we could simply just find area of the circle. You don't have to find like two sectors separate or like one sector and then multiply by 2. The two semicircles form a circle, right? So the area of the circle will actually just be pi r squared, which is 22/7 multiplied by 3.5 divided by 2, right? Which is the radius squared. So give me the answer here now. What would be the area of the circle?
37.62.
Somebody is second, 37.62. I ain't hear nobody second in that way.
I got 19.25.
Any 19.25?
Yes, sir.
Yes, sir.
19.25. So check over who got 37. 19.25.
I get 9.625 instead, sir.
Whoa. No. Check over that. 22/7 multiplied by put 3 point, your open bracket, or you can just put I think it's what y'all got for the radius, yeah?
1.75.
Right, let me put higher because it's probably confusing people, right? So I put a little work in here. Radius is equal to 3.5 divided by 2, which is 1.75 meters. That is your radius. So it's multiplied by your radius squared, which will be multiplied by 1.75 squared. And what y'all getting there?
9.625.
I hear 9.625. So where did 19 come from?
Yes, sir, that's correct.
9.625. So it'd be 9.3.
Yeah.
Sorry, 9.625. 9.63, right?
Yes, sir.
Yes, sir.
The amount
Yes,
that
sir.
times.
That is the same answer I have, sir.
That the amount of times that that answer changed. That was the first answer Amelia gave me.
Yeah,
Right,
that was
so-
the first answer.
Very good. So area of compound, not compound shape, but the area of the swimming pool, because that's what they asked us for. Area of swimming pool. So area of swimming pool would be the 9.63 plus the 28. And what do we get in there?
37.63.
Yes, sir.
37.63.
37.63.
That's correct.
All right, very good. So this will be equal to 37.63 meters squared. All right? So that is the area of my swimming pool. Now, before we go up to those questions above, it has some questions. Hold on, guys. Anybody else writing here? Raise your hand if you're writing. Right, I want to put in some questions at the base here. I had it on our next worksheet and I was like, that's some good hard questions to do. It's actually the same worksheet that we did, but it had some different questions in between, right? So I just want to put those questions on this worksheet. Right, like this is May 2023. So May 2023. Copy. Right. Right. Look, this on January 2023, similar to the one we just do there. So I want to get them done now. Practice is everything, guys? Practice is everything. Copy. All right, we do this one already. There's not much extra, this one. All right, January 2020. And January 2025. Right. Somebody mic on. Right. Okay, so we still have 30 minutes. I want to do some of the harder questions. I'll leave the easier ones so you all to complete for homework, right? Now, since we just come off this one, right? I want you all to try this one. This is January 2023. I'm giving you all 3 minutes to try this quickly. 3 minutes. So the diagram below shows a scaled drawing of a running track. It consists of a rectangle and two semicircles with diameters Ln and MP. Ln is equal to MP, which is equal to 49 meters. And Lm is equal to NP, which is equal to 98 meters. Almost identical to the question we just did, right? So Jalen, listener, show the total length around the running track is 350 meters. Now, if I ask the total length around the running track, what am I asking for? My what?
The perimeter.
The perimeter.
Boom. Very good. Perimeter. So we know here is 98. The question also told us that here is 98 meters also. That's from here to here. What we need to find here, my children? What we need to find? What missing?
The arc.
The arc.
Arc. Two arcs.
arc.
Well, it's two arcs, right? So you have an arc here, you have an arc here. So let's work. Let's work, right? So basically, we're going to find the length. All right, so is length of... Now, you all realize, I want to put this, but I want to make sure everybody understand. Ali Marie, tell me if I'm talking shitness. Would these two arcs make up a whole circle? Can I just find the length, the circumference of the circle?
Yes, sir.
Right. So I want
Yes,
to do that
sir.
instead. I just want to find the circumference of the circle. Right? So circumference of circle. Right? Which will be the two semicircles coming together, right? And that will simply be 2 pi r, or diameter by, right, diameter by 2 by pi, sorry, it's the same thing, right? So it'll simply be diameter by pi 2 is the same working, right? So the diameter is 49 multiplied by 22 over 7. And what we get in here? What is the circumference of the circle? Anybody?
154.
154.
Right? If you took any other route, you should have gotten the same thing for the lengths of the two arcs together. Right? Any route you took, you should have gotten the same thing. So therefore, the length of running track would be equal to 154, which is the two semicircles, the arcs, plus 98 plus 98. And when we work on this, are we getting the 350? Are we getting 350, guys?
Yes, sir.
Yes, sir. Yes, sir.
350 meters. And you put a box to indicate that your proof was shown, right? Or you can write the word shown, because it's something they asked us to show, right? Almost identical to what we just did. Now, if you didn't want to do it like how I did it, you could have found the length of one arc. Then you just have the length of that arc plus the length of the other arc. I think I should still do it because that's how I showed you all. I would have shown you all a different route, right? So if we proceeded to find the length of arc, right? It would have been theta, which is 180 in this case. Theta over 360 multiplied by 2 multiplied by pi, which is 22 over 7 multiplied by radius, which is 49 over 9. And when you work on this, guys, anybody who took this route? What you got there for the length of the arc?
This route. And I didn't finish, but I did get 83.84.
I put 49 over 9. It's supposed to be 49 over 2.
Excuse me, sir.
Right.
Can I be excused?
Sure, no problem. Anybody worked out this for the length of the arc?
So wait, I have a question.
77, sir.
Yes, 77. That's why again.
Sir?
77. Yeah, go ahead.
It's 77.
So I realized
Joshua?
I did went wrong. I put 49 over 360 instead of 180. I didn't.
49 over 1. Oh, okay. So, yes, 180. So, here will be 7. I understand what you're saying, Josh. So, here will be 77. And over here will be 77 also. Right? And then when you add up all, it's supposed to get the same 350. Okay? If you took the length of the arc route, you would have gotten the same answer. So raise your hand if you're good here. You say, right? So Nathan walks at a constant rate of 1.4 meters per second. Calculate the time it will take him to walk 7 laps. We're going to utilize the speed formula. Speed is equal to, this is primary school. Speed is equal to what? Who knows?
Distance
Speed is equal to distance over, excellent, right? Over time. That's a standard formula. Okay? Now, from this formula, we can actually get time is equal to distance divided by speed. Right? So write down these formulas. And you could also get distance is equal to speed multiplied by time. Okay, but let's write down these two for now. So speed is equal to distance over time, which means time is equal to distance over speed, right? You could get the second formula from the first, right? Now, we know what the speed is because Nathan walks at a constant rate of 1.4 meters per second, right? So your speed is equal to 1.4 meters per second. Now, what we need to find is my distance. So what is the length around the field, Rudra? Rudra, what is the length around the field again?
Sir, can you scroll up because I didn't finish writing, sir?
Oh, I didn't get a chance to write.
So it's 350 meters.
Anybody need to write? Raise your hand if you need to write. Those who have their hands up, put your hands down. Because sometimes when students have their hands up for a question, it has so much hands up, I wouldn't know who asking what now. All right, you'll take a little minute to write. Because they need this information for the questions we got already. Scrolling back down. Right, so I was with Rudra. What is the distance around the field, Rudra?
The distance around the field is 350 meters.
And how much laps did Nathan make?
Nathan made 7 laps.
So what is his total distance? Nathan's total distance?
Nathan's total distance would be
350 is 1 lap. He makes 7 laps. How would I calculate that?
Yeah. 350 multiplied by 7.
By 7.
Right. And what we get when we multiply that, guys?
2,400.
2,450.
400.
So 2,450 meters big man walk, right? He real walk. But we have a formula to find time. The question asks us to calculate the time. So time is equal to distance over speed, right? We have a formula here. Let's work your formula, right? So time will be equal to what here, Nathan Ford? Nathaniel Ford, sorry. What is distance?
Say him.
Yeah? What is distance?
Distance is the 2,450.
Divided by what is my time? Not time, speed.
Speed is 1.4 meters per second.
Right, so just 1.4. So when we divide this, what would be my time? How many seconds is this taking? Because we are in seconds.
Can I answer,
Ed,
sir?
how much you'll get?
1,750, sir.
750.
1,750
50.
1,750.
flat seconds, Because remember, it was meters per second. Joshua and Abijah, you all hands up. You all have any questions?
Oh, no, sir, I forgot to put down my hand, sorry.
All right. So those who have to write it, right? Right. Everybody should have this, right?
Yes, sir.
So those who finish, I want you all to try part B. It's like a common sense question. Try part B. So you all see the questions is not going to be all easy all the time, I'm glad we did this question because this is one of the hardest questions on the worksheet. So guys, more than likely, next class, we might spend like half of the class correcting the homework. And then I want to move on to graphs. So you all must have your graph paper for next week. You must have your graph paper for next week. Okay? Half of the class to finish correct all the homework and half to start graphs. Or even if we take the last hour. Go ahead.
You could put up the reminder on the group chat.
Yeah, I'll put up a reminder. I'll remind you all today and I'll probably remind you all closer to the date too. But you must have graph paper and you all need to get your scientific calculators, please. Please. Hey, so if big man taking 68 seconds to run one lap and they're asking you how much he will complete, how much laps, right? He will complete in 1 hour. What are we doing here? Anybody? Divide.
Yes,
But what we divided? What's the first thing we had to do?
Change 68.
Change the hour into seconds.
The hour into minutes.
Right, excellent. So let me ask Orozco. Orozco, how many hours, how many seconds in an hour? That's very good, whoever said that. You gotta change the hours to seconds. Orozco.
Yes, sir.
How many seconds in an hour?
Sorry, sure.
How are we working it out? Orozco.
So isn't it 60 minutes an hour?
60 minutes in an hour.
So it's
How many?
3,666
3,600. 3,600.
That's all.
Yes, sir.
Here is 60 multiplied by 60. Right? 60 seconds in a minute and 60 minutes in an hour. So it'd be 3,600 seconds in 1 hour, right?
Yes, sir.
And how much is Tafari taking to run one lap?
38 seconds.
Right. So,
I mean,
so
68.
Safari.
68.
68.
About
Yeah,
68.
Safari ran. So Safari ran. So it'll be 3,600 divided by 68. How much approximately he running? How much laps?
52 or 53 laps.
Yeah, we're not approximating. If it's
52.94.
right, so watch it. If it's 52,
94.
if it's 52.94, right, it means he didn't complete that last lap. So therefore, how much laps did he complete? They say how much laps did he complete?
52.
52.94.
Therefore, Safari complete. Somebody mic on. 52 laps in 1 hour. All right? 52 laps in 1 hour is what Safari completed, right?
But
Now this one here.
I didn't get to finish it.
Yeah, go ahead.
Thanks.
Right. I was going to say one more thing about here, right? Point to note, guys, when you're looking like how they ask you to calculate the least number of laps it will take to complete before they reach the same point again. For the time you see the word least, you need to find the LCM. That's my little hint for part 2. So go on. Copy down those who are to copy down part B. Copy down those who have finished. The hint is to find the least number of laps. For the time you see the keyword least, you know you have to find the LCM, right? So you can write this as a note. Keyword. So anytime you see least, minimum, smallest, these all imply LCM, right? And anytime you see maximum, most, greatest, these imply you need to find the HCF. Very important, eh? Very important. So we must first find the least amount of seconds, not minutes. I'm going to say minutes. The least amount of seconds it will take, right? So I'm going to put here least amount or least number of seconds. Right? You have to find the LCM. Find LCM of 68 and 72. Right? I'm going to do the working right here. 68, 72. So you'll have 2. You say 2 into 68 is 34. 2 into 72 would be 36. Use 2 again. 2 into 34 would be 17. And 2 into 36 would be 18. You can use 2 again. 2, you bring down the 17. Now this is primary school looking for LCM. 2 into 18 is 9. Right? Then you use 3 because you can't use 2 anymore. Right? 3 into, 3 cannot go to 17, you bring down 17. 3 into 9, 3. Then you use 3 one more time. Bring down the 17. 3 into 3 is 1. And then you just use 17. 17 into 17 is 1. You bring down the 1. So therefore, LCM would be equal to 2 to the third power, because it's 2 multiplied by itself 3 times, multiplied by 3 to the second power, multiplied by 17. So what would my LCM here be, anybody? Work it out for me. What's the LCM? So somebody work out these here to find out what each one took, the amount of laps that each one took to complete or reach back at the same point L.
So Safari would take 18 laps and Nathan would take
Excellent.
17 laps.
Excellent. Right? 70 laps.
That's correct, sir.
Right? So copy it down, because I know you all will need to copy down, right? So once again, we found the LCM of 68 and 72, because they want the least number of laps, so we found the least number of seconds first. We got 1,224 seconds. We divided 1,224 by 68 to find out how much laps Tafari would take, and then we divided 1,224 by 72 to find out how many laps Nathan would take. Right, guys? So copy this down.